Hello again. Today we're going to take Notes 5 called Multi-Step Special Cases. We've been working on solving multi-step equations for a couple of days now. Again, a multi-step equation is when you have variables on both sides of the equation and you have to do lots of steps in order to find out what x is. There are two times where you have a special answer. Most of the time, you're going to have one number as an answer, but sometimes funny things happen, and so I want to show you what those funny things are today. We're going to follow the same steps as before. The first step, again, was to get rid of subtraction. So we're going to do that first. I have lots of subtractions here. So this, remember what goes in front of the x when there's nothing? There's an invisible 1 there. And so I need to get rid of the subtraction by making this plus, and this becomes a negative 1x. And here's a subtraction, so I make this a plus, and we take the opposite of 5, which is negative 5. And I just write the new number above, and then I have one more subtraction, plus a negative 9. After I get rid of subtraction, my next goal is to distribute and simplify. Looking at just the left side of the equation, I look to see if we have any like terms, and I do. I have a 3x and a negative 1. I'm going to combine those like terms. 3 plus negative 1, those sides are different, so we subtract. And I'm left with 2x is equal to negative 5. I cannot combine those, they're not like terms, so the right side is all the way simplified. Excuse me, the left side. On the right side, I have the distributive property. 2 times x is 2x. 2 times 2 is 4. And then that plus 9 just stays there. Plus negative 9, we just copy it down. I have like terms. My constants are like terms, so I can combine the 4 and the negative 9. And I'm left with 2x, 4 plus negative 9. Those signs are different, so we subtract them. 9 minus 4 is 5. And the 9 is bigger, so it stays negative. And then if you look, you might start to see something curious. You have 2x plus negative 5 on this side and 2x plus negative 5 on this side. That is sneaky. After we distribute and simplify, we get the variable on one side. These are the same steps that we've been working with. I'm going to move the 2x over here. Normally, again, I move the smaller one, but when they're the same, it doesn't really matter. So I'm going to take away 2x, take away 2x. And when I do, the 2x is canceled, leaving me with a negative 5. And this is what's weird. On this side, the 2x is also canceled, and I'm left with a negative 5. Did you just see what happened? All of the variables canceled. All variables canceled. I have no more variables. That is so weird. When that happens, it's called a special case. This only happens sometimes. When it happens, we have different answers. There's not a number that we can have for x to make this true. There's lots for this one. Do you see how when negative 5 is equal to negative 5, that's a true statement, right? Negative 5 is negative 5. When the variables cancel and you have something that's true, the answer is all real numbers. What that means is that every number in the whole world, if I plug it in, I get a true statement. If I put in a 0, I put a 0 here, a 0 here, and a 0 here, and I simplify this, I'm going to get negative 5 is equal to negative 5. If I plug in a 2 for x, I would get this side is equal to this side when I simplified. If I picked a 27, I plugged in a 27 into all the x's, this side would equal to this side. That would happen with any number, and that's why it's called a special case, and the answer is any number, literally any real number. That's the first kind of special case. There's one other one. Let's solve this one and see how it works. We're going to do everything the same. Draw a line through the equal sign. I'm going to get rid of my subtraction. So this becomes a negative 2, a negative 4x, and a negative 9x. If you feel comfortable not adding the opposite, you don't have to. I personally always do, because otherwise I forget what's negative and what's a minus, and I